All right, so let's go ahead and talk about part one, which is classifying real numbers. So I've drawn our Venn diagram here. Natural is in the middle, then whole, integer, rational. Irrational is on the side, and real is every number we know. So natural numbers are our counting numbers, 1, 2, 3, 4, so on and so forth. Whole numbers are all of the natural numbers plus 0. Remember, the only difference between the whole numbers and natural is 0. Then integers are all the whole numbers, all the natural numbers, plus their opposites, so including negatives, -5, all of that. As soon as we get fractions and decimals, we're looking at rational or irrational. Rational means the decimal terminates or it stops or it starts repeating. Irrational means that as soon as you get a decimal and it goes on forever and it's not repeating, that's irrational. And then real is everything we know. So we're going to go through these and determine what category they fall into. So here, -3/4. Okay, well, that's a fraction, so it cannot be natural, whole, or integer. So I'm looking at rational or irrational. Well, -3/4, if I put it in the calculator and I do alpha y equals, that gives me the fraction. I do -3/4. Well, and I want to make that a decimal, I hit math, answer to decimal. -0.75. Okay, well, that decimal stops, so it is rational. Okay, then I'm going to do the square root of 100. So to get a square root, you do second x squared, and we have the square root of 100. Well, that's 10. Well, where would 10 go? 10 is a natural number. I can count to 10. If it's natural, it's also a whole number, also an integer, also rational, and if it's rational, it cannot be irrational. -2.3 repeating. Okay, it's a decimal, so we're looking at rational or irrational. It repeats, so it is rational. 64, I could count to 64, so that's a natural number. 64 is also a whole number. It's also an integer and rational. Square root of 17, so I type that in my calculator. Second x squared, and I get 17. Okay, so square root of 17. Hit enter. It is a decimal, okay? So as soon as you get a square root and it's a decimal, it's an irrational number. So if you get a square root and it comes out to be a whole number, it's not irrational, but as soon as you get a decimal and it's a square root, it is irrational. Okay, 0. Well, 0 is not part of the counting numbers. It's not natural. We start at 1 there. It is a whole number. It's the only difference between the whole numbers and the natural numbers. And if it's a whole number, it's also an integer and rational. 1.374129. Okay, this decimal is going on forever, and it does not look like it's repeating, so it's irrational. 7 to the power of 4, I can do that in the calculator. 7, to get the exponent of 4, you hit the caret symbol, and then we have 4. 2401, 2,401. I could count to it. It would take me a while, but I could count to it. It is a whole number. It is an integer. It is rational. -44, okay, it's negative, so it cannot be a natural or a whole number. There's no negatives. However, it's not a decimal, so it could be an integer. And if it's an integer, it's also rational. Last but not least, 129. I can count to that. If I can count to it, it's also a whole number, also an integer, and also rational.